Now, before we begin to write the entry point of our program, that is the Index.js, we need to install something. When you look at our package, you can see all the dependencies that we have: Express, HTTP, MQTT, Postgres, and Socket.io. We need to make a last installment for EJS. EJS, embedded JavaScript. It allows us to embed data into HTML file. For example, if we query our database and we get rows of data, we can decide to embed it inside HTML. So go to your terminal and move back to the main application, that is the server, and we will do npm install EJS. Now the package is installed. It looked like it required root access. Open your Index.js with VS Code or whatever editor you are using. First, we will get Express. We will get MQTT. We will make app out of the Express if you know how Express works. Then we will get the port. As I said, we are going to run it on localhost, so we could make it port 3000. And this is the Node.js server, so that when you go into your browser, you can type http:// your IP address :3000. Then we can get the HTTP. To require HTTP. Next, we can get a server out of the HTTP that we created, the http.create server. And inside the server, we will add the app, this app that we got from the Express. We will get a path object because we will be serving static files on the web client. The next one, we will do this server and we will require Socket.io. We are going to use Socket.io and we need a server to do that. So once we have this, we can do io is equal to, then we call the server that we have already defined up here. So we create a new instance out of that server and we pass in the HTTP server, right? So we need to create a server for the Socket.io. Whenever a request comes in, it needs to be routed. Can define constant routes. We go back into the source, and source we get routes, and you get the Index.js. And the last thing, we can get sensor module, source modules, and sensors.module. We will set up the embedded JavaScript. We call the app.set. We call view engine, that is the default name for this, and we will use EJS. Now we also want to specify a directory which will contain the static files, that is our web pages. So we can do app.set. We need to specify from which directory we are serving our static files. So we will do views like that. Then we call the path object that we created, then join directory name, and we want to be serving from the public directory. We are not going to save every sensor data or row of sensor data that comes in. So we create a buffer, and for example, we will save about 5 minutes of data inside this buffer. After the buffer is completed, we will find the average and we will save the average inside the database. Let sensor buffer. We will set it to empty array, middleware to parse JSON data. We are going to use express.json. We call it like that. Now we will add routing here so that when HTTP request comes in, it will route it to the appropriate API. So we can do app.use. We will say like API, which means that whenever a request comes in and it has this after the domain name, right, then it will be routed to this. Now it's time to set up the MQTT. So we can just create a constant and call it MQTT client. And this one, we are going to call the MQTT that we created up here, this. So we do MQTT and connect. Now inside this connect, we are going to add this, and also we will add our IP address. Now the IP address that my Raspberry Pi has is this. Look at yours. You can go to your Linux terminal and type ifconfig. It will show you the IP address. So we type in the IP address and we type in the default for. Once we have our MQTT object, we are going to define two main functions. That is when the MQTT is connected and also when message comes in. We will do MQTT client that we just defined above on connect. We are going to call this JavaScript function. For debugging purposes, you can print something to the console connected to MQTT Broker. So when connection is made, what we can do is we can subscribe to a particular topic. So we can do MQTT client.subscribe, and when we looked at the code that we wrote for the ESP32 client, we created this subscription home.census/data in case we catch any error. Okay, make sure you bring the semicolon here. We can print it to the console. You say failed to subscribe, we can put in the error. In case you have another topic, subscribe to a different topic. Now we will leave this entirely just as we've done for MQTT client.onConnect. That is when we are connected. We can also do that when message comes in, right? And we decide what to do with the message. We can decide to save the message, or also we can decide to send the message to update the web client, right? So we will do MQTT client dot, this time on message, right? So when we have a message, we want this to be async, right? So that it can work in the background. We pass in the topic and also the message. We need to make sure that this is the topic that we are expecting. For example, we might be publishing a couple of topics. So once we know the topic, then we can route it properly. If topic is equal to what we are expecting, this time we are expecting home/census/data, constant get payload string. And we will call the message and we will convert it to string. Payload string received. Once we are done, we can convert the string into appropriate format that we need. We'll be passing it as JavaScript object, an object that has the fields of temperature, pressure, air quality, and light intensity. We will say sensor data. We will create a function and call it convert payload string to object. We will pass the string inside it. You can do console.log sensor data, right? When this is complete, we can update the web client, right? And we said we will be using the socket IO for real-time communication for the web client. So the object that we created for the socket IO is here, IO. So inside here, we will call this emit, and we give a name for it, sensor data. The working principle of the socket IO is easy. All that you need to do is that you need to emit data and you go to where you want to get that data. For example, when we start writing the HTML, we will call socket IO object and we will do, for example, socket.on. Whenever we receive this on sensor.data, then we can retrieve this object. Okay, then we can decide to save the sensor data that we have received. That is the average. Save average sensor data. This function we've not created yet, but we will create. So we have two main functions that we will create. We have this to convert the incoming string to object, and also this function that will save the average of the sensor data that we have recorded over a period of 5 minutes. Move down and we need to define few endpoints. We will do a get request. When somebody visits the home like this, we want to see if the page is working, right? So request response console.log, we will say hello world, then we can return response. Then we can just pass a message like data received. Do app.get/graph, the request comes in, the response showing graph. After that, we are going to serve the request with the static HTML file. So we can do res.send file. We add the directory where the files are, and the files are located in the public/graph.html. I mean, when you go inside the public, we are going to create two HTML files. One will be graph.html and the other will be detail.html. In here, we will do app.get detail request response. We will do try because we will be accessing the database. So we say constant data, and this is why we define the sensor model. We imported it here. If you go up, you see the sensor model. We want to access the database directly. Sensor model, then we get all sensor data and we will send the response. Now we will be using the EJS embedded JavaScript. So with that, you call res.render, we give the file name. The data that we queried from the database, we want to embed it inside the HTML. So we do it like this. And that is all. Here we are assuming that you are using a template engine. After this try, in case we get an error, we will catch the error like that. Error retrieving data. We have to make this also async. The next thing that we will do is that we will create the connection for the socket IO. So IO.on, this time on connection, we will create an object and call it socket. And we will say that a user connected to socket IO. On the web client, the user will have the opportunity to either turn on or turn off a sensor, and we are going to use checkbox for that. We will do socket.on, and this time we will call it checkbox data. When such data comes in, we will get the data like this. Once we have the data that we want to send to the client, we need to call the MQTT client and we publish that data. So we can call MQTT client that we defined above, then we will say publish. Let's create a topic and call it ESP/CMD. Then we will pass the data that we received from the web, that is the checkbox data. And basically that is all. Whenever we get data from the web client, send it to the ESP32, and when it goes to the ESP32, it will take it and it will execute it. When somebody goes to the website and he goes to the detail.html and he wants to see the sensor data that has been recorded over a period of time, the web client does not contain the database. The database is part of the server. So what we are going to do is that we are going to use the socket IO to emit something to the server. The server will receive it and the server will perform the database query. Now when the server performs the database query, it will send back the results to be updated on the web client. Now we will create this socket and we will call it search time range. This is going to be asynchronous. We are expecting a search time from the user or the client. Inside here, we are going inside the database to retrieve the time period the user wants to see. Return data, and this time we call the sensor model and we will get sensor data within range that we defined, and we will pass the search time just like that. After retrieving it, we will emit it back to the client. So what is important is that you emit it on a different channel. So you use a different name, received range, and we will send the return data. So when we go to the client and we also do socket.on rec range, it will give us the data. That is the simplicity of using socket IO. We call two functions that we have not defined yet, so we can start defining them. So convert payload string to object. Go down here and let's create that function. So this function, as we define, is going to take as parameter a string. Okay, so we will pass a parameter like payload string. As we said, when we get the string, we are going to convert it into a JavaScript object. We will kind of split the string using the split command into an array. So now we are going to call the split function on the string that we will be receiving, which means that the four sensors that we have will be sending the values like temperature, pressure, air quality, and light intensity. So we will split them into an array and we will return an object. We can do return object. We give the field for the object. So let's say, but we need to convert them to float. That is how we define our project. The first value will be for temperature. The second will be for pressure. The next one will be air quality. The last will be the light intensity. So this function will pass the string and convert it to a JavaScript object. Delete this semicolon. The last function we need to define is the function to save the average sensor data. So scroll to the bottom and let's define the function async. We paste the name and it is going to take the data. Now first, let us push it to the buffer that we created. As we said, we are not going to store every sensor data that we get, but rather we will put them inside the buffer, and when the data is collected over 5 minutes, okay, then we will find the average and send it. We will do push and we push the data inside here. Now we will write our logic here. We are going to send sensor data from the client every 5 seconds. If that is the case, it means that we will have 60 samples in 5 minutes. Okay, so whenever we check the length of the buffer and it is greater than or equal to 60, then we can say that okay, we've collected data over a period of 5 minutes. So we can do if sensor buffer.length, right? If it is greater than or equal to 60. So inside here we will find the average sensor data that we want to save inside the database. So we will create the variables. We will start with the temperature, average temperature. We will call the buffer here, and we are going to use the JavaScript reduce function. We call the reduce, and we are going to sum all the temperature values. After that, we will divide by the length of the sensor buffer. So here we can put sensor buffer.length. Okay, now come back inside and let's write the JavaScript function to do that. We are going to loop through all of them and add the temperature variable, and we bring 0. What we can do is we can just copy it for the rest. You can copy and paste it 4 times. So when you come here, it will be d.pressure, average air quality, and the last one will be the light intensity. Once we have this, we can put them back into a JavaScript object and we call the API to save it. So we can do constant, maybe save object, temperature, we convert it to float as usual, average temperature, and we only want 2 decimal places. We will do the same for the rest. So this is the object that we have created. Then we can call the API to save it. After saving it in the database, it will return the results. Then because we are going to call the model to do that, we need to make it async. Then we will call the create sensor data that we created for the API, and we will pass the save object, save obj. Correct this one. Let's make it like this. So after saving it, we can print to the console and see if the return value was correct. Then after that, we need to clear the buffer so that it will store the next 60 row of values that will be coming from the ESP32 client. You make it empty. Alright, that is all for this. We just do server.listen. We created the port already. Server is running on this port. So this is all for the MQTT broker. Okay, so we are calling our MQTT functions and also the WebSocket that will communicate between this server and the client. The last thing that we will need to do is to go inside the public directory and create the 2 static files that we need